Hello. Wait, it's not on? Man, technology's hard.
No, that one, the other one.
This one? I know I turned it on.
Yeah.
I did that already. Hello? Y'all hear me? Good. Anybody mind if I do? Whoa. Now I feel like a rock star.
Down a notch.
Yeah. No, I was going to ask if anybody minds if I do it in English. Anybody? That's good, 'cause you didn't really have a choice. I was just wondering. All right. So my name's Aaron Greenwald, like she said. And this talks about tests and code and how tests are code. So if you look at most code bases, what you'll discover is that I like to think, let's say it this way. I like to think of code bases as a city, okay? And if the city of our code base is Tel Aviv, then our production code looks something like Ikar Medina, and our test looks something like, well, maybe it's not nice to say this, but Tachana Markazit. And, you know, because nobody really cares, right? And they kind of just like, yeah, we take care, then we talk about clean code, but we don't really talk about clean code when we talk about tests. And so that's what I'm here to change. Before we start, a couple of questions. Show of hands, how many people here have tests in their code? Okay, most of you, that's really good. Of you that have tests, how many are proud of the way their tests look? I'm not one of them, I'm just, all right, so good. So this is what we're gonna talk about. And I wanna preface it by saying, what do I mean when I talk about tests? Because people talk about tests a lot, and there are a lot of very strong opinions in the testing community. And when we talk about tests, we often have all kinds of different expectations of what people mean when they say the word test. So I'm going to say this. I work off the testing pyramid, the old school way of thinking about tests that nowadays, you know, some revolutionary radicals have other shapes for the testing pyramid that are not pyramids, right? Personally, if you ask me, none of them are pyramids. It's a triangle, okay? I've never seen a 3D implementation of this. It's always a triangle. But the testing triangle looks something like this for those who aren't familiar. On the bottom, you have unit tests, okay? Unit tests are tests that essentially address very small pieces of code, a single function, a method, a class, whatever you call it. And you have a lot of them. That's why it's in the bottom of the pyramid. A little bit on top of that, a bit of a narrower bit, meaning there are fewer of them. You have what we call integration tests. These are sometimes called component tests in the world of React. These take multiple units, put them together, and check that they work together properly. And then on top of that, you have what we call E2E tests, sometimes UI tests, functional tests, a million different names for these things. These essentially simulate a user. They stand in place of the user. They address the code from the outside as a third. It's a black box. They try to do something and make sure that the application behaves the way it's expected to behave. There's the triangle, and then whenever you present this triangle / pyramid, you get a lot of people have very, very, very strong arguments about what exactly a unit is. I remember in the world of Redux, we had people arguing about how low of a resolution you were supposed to go to have a unit test, and was it really a unit test, or is it just a fake unit test? It's not really a unit test because it's an integration test. I don't know, I don't care, okay? To me, the whole thing is a gradient. It's not really 3 distinct points. There's a lot of the tests on the bottom that are very small. How low you go is a judgment call, and as you go up the stack and you go higher in levels of abstraction, you have fewer of those tests. The reason for this is simply because you have the higher up in the level of abstraction, the more coverage you get out of each test, the more they actually test the thing you're trying to test, but the less easy they are to use, because when they fail, you don't know why they failed, you have to do a lot of research, they're flaky, blah, blah, blah. So we have this kind of shape where we have a lot of the unit tests and a few of the E2E tests and somewhere in the middle of the things in the middle. All right? When I talk about tests in this talk, I mean all those kinds of things. And by all those kinds of things, I mean all these kinds of things, okay? Whatever library you're using, and in the 5 minutes since I started, probably another 3 libraries were invented. I don't know what they are. I don't know. This talk is about those things too, okay? Anything that's basically, you're writing code to write tests in JavaScript, that's what I'm talking about. All right, with that out of the way, let's talk about why we care about having clean code in our tests. The first thing I'll say is that maybe we don't, you know, it's legitimate. There are people who will tell you, you know, your tests don't really need to be clean. It's not such a big deal. What's the purpose of a test anyway, right? So my colleague, Maura Frankel, who's sitting right here in the front row, he has a saying. He says, the purpose of a test is not to pass. The purpose of a test is to fail. And that's true. The whole point of a test is to fail. If the test never fails, then you don't need the test. It doesn't do anything for you, right? And so if that's the case, well, if the test can fail when things go wrong, it does its job. Who cares if it's clean or not? All right? And there's something to that argument. I'll grant you that. okay? Because I once worked with somebody who he was a big believer in tests, and he came across some tests that I wrote, didn't think they were very clean, so he deleted them. And then we had a regression in that area of the code. People weren't so happy after that, okay? Don't do that, all right? You know, don't get too hung up on having clean tests, okay? Ugly tests are better than no tests. I'll say that. But with that out of the way, I'm not going to end my talk right now. Sorry. We're going to keep talking because we do care about having clean code in our tests. And we care for the same reasons that you heard in the first two talks of the evening, which is you want to have easier maintenance, you want to have easier reliability, and et cetera. All those reasons, just like they apply to production code, they apply to tests. There's no difference, okay? If you care about the people in the rich areas of your town, you should care about the people in the poor people. Okay, I don't know, maybe you don't. I'm not getting into politics. But if you care about your production code, then you should care about your test code, okay? That's it. Simple, right? But I argue that there's even more. In fact, I'm going to make the case tonight that it's more important to have clean code in your tests than it is to have in your production code. Clean code is more important in tests than production. And in order to understand that, which is a fairly aggressive statement, in order to understand that, we need to go a little bit back to why we write tests altogether, okay? So why do we write tests? All right, so that they will fail. In other words, to prevent bugs. Okay, that's the classic reason. It's the first reason. It's the main reason we have tests altogether. True. But there are other reasons. For example, having tests helps us remediate our bugs. What do I mean by that? Sometimes you write a test before you put your code in, and you put your code in and it works, and because you had the test, your users didn't run into a bug, and that's great. Sometimes you don't have the test because your tests aren't perfect. You don't have perfect coverage. Even if you have 100% line coverage, you don't really cover everything. And then you get a bug report from the field. Somebody reports a bug. And so while you're trying to research that and dig into it, the tests that already exist will help guide you toward that bug sometimes, okay? As you read those tests, you start to understand what's happening. And when it's time, when you're under pressure and you need to fix that bug, the tests that already exist allow you to just add one more test that handles this one more edge case, know that everything else is okay, and push it out. So tests help with that too. Tests help with your velocity. There's a lot of overlap, but what I just talked about is also, in a sense, velocity. But here I'm talking about the fact that tests allow you to push out code faster. Why? Because without tests, you really can't have any kind of continuous delivery system. At least I can't imagine it, okay? Any organization that's properly pushing out code all the time without huge manual QA processes and approval processes and all kinds of gating has to have good test coverage. So test coverage helps your velocity. Test coverage helps your confidence, okay? It helps you feel better about knowing what your code does. That means that when it's time to refactor, you can refactor confidently because you know that you're not going to be breaking things. It helps you know when you release that you're releasing safely. Yes, I know there's a lot of overlap in these bullet points. I'm not trying to list here distinct things. I'm trying to give you an idea of what in general you can gain from testing. Test helps you design your code. This is a big school of thought and a whole other topic in itself, TDD. But writing tests can help guide you when you write your code, help you figure out how your code should look. That's another benefit of writing tests. And of course, tests help document your code. I don't mean documentation for users or even for people, or maybe for programmers who are using your code as an API, but for yourself. When you come in later to the code and you have those WTFs and you say, what's this for? If the tests are written well, then they'll help you understand why the code is the way it is. And they'll help you understand what this method or this class is supposed to do, because it says it should do this and that and the other thing. And finally, last two somewhat whimsical reasons. A lot of us write tests because it's good for our resumes. That's called resume-driven development. Okay, if we're being honest, you want to get a job, it's 2019. You want to be able to say you wrote tests. It's the truth. And also it feels good, okay? I don't know, maybe other people don't like it. When I first started writing tests, I didn't like it. I thought it was slowing me down, it was a hassle. I love writing tests now. I feel so satisfied when I bang out like some code and just the tests are all green. I don't know, I just like it, I like it. All right, so now let's go back to why we care. Why do we care about writing tests? Because of all those reasons. I'm sorry, why do we care about writing clean code? Because of all those reasons. Let me go back to that story that I told you about my coworker who deleted the code. So one day, what really happens, one day I come in, it's a Sunday morning, and there's a regression, and everybody's worried about this regression, and I'm just thinking, I don't understand how this happened. I could have swore there was a test there. So I do a little digging in the commits that were made over the weekend, and I see that the test was deleted. So I asked the guy, like, well, I don't understand. You had a test. He said, yeah, but the test wasn't working. So what do you mean the test wasn't working? He says, well, I ran the code, I ran the test, and it was hanging. And then after 30 seconds, I just got an error. I said, okay, but they were failing, right? Did you try saying, like, stash your changes, and let's see? And if you were to stash your changes, you'd see that tests are green. Unstash your changes, they're red. Stash your changes, they're green. Unstash, they're red. Maybe your code's broken, right? So maybe the test is doing its job. So why are you deleting the code? And, so we had a conversation about that. And I still think that it was wrong for him to delete the code, because if you stash your changes and the tests are green, and then you unstash your changes and they're red, then there's probably something wrong with your code, right? But there's also something wrong with my test there, because if he's running his test suite and he sees something hanging and he has no idea why, how is he supposed to fix that? How is he supposed to understand what's going on? That's not a clean test. What was happening there was one of those ugly tests where you have to wait to see if something happens or not. And since you don't know how long it's going to take, you wait until the timeout, which was in this case 30 seconds. And if it times out, then the test fails. And if it doesn't time out because it worked, then it works. So if it only fails after 30 seconds, I'm going to call that not clean. And I understand why he deleted it, even though I don't think it was right. So I'm going to say that one of the reasons you need to have clean tests is because without that, they won't last. All right? If you want your tests to stay in production, to stay in your code base, then they need to be clean. Nobody, at least I've never seen it happen, somebody come and say, this production code, it probably does some features and stuff, but it's so messy and it's a hassle to deal with and nobody knows what it does anyway, so let's just delete it, right? People don't do that because they understand that, probably some users using this feature, even if I don't understand it, I have to leave it in. But for some reason, when it comes to tests, people see, whenever I see people have tests that are messy, they're hassle, they're flaky, we're not sure if they're working, we don't understand what they're doing, just disable them because we have to get this release out. So the first reason you have to have clean tests, in addition to all the reasons that your code needs to be clean, is because if you don't have clean tests, you won't have tests. And a test, if the main purpose of a test is to fail, then a test that doesn't exist is not going to fail. But also so that they explain. In other words, if your tests aren't properly documenting, then they're not doing one of their jobs. Since a good chunk of the purpose of your tests is not just bug prevention, but let's look at this list again, right? Let's highlight remediation, documentation, which are for us, not for our users. So if the purpose of our tests is not just for our users, in other words, to prevent bugs so that they won't have bugs, but also for us so that we will have a better time fixing bugs and a better time reading our code, then it's not just that if they're ugly, it's a pain in the neck. If they're ugly, they're not doing one of their key functions. That's their job. So what's the point of having a test if it isn't doing one of its jobs? Okay, it's doing one of its jobs, it's preventing bugs, but half of its job it's not doing. That would be like, does anybody here speak Chinese? So I don't speak Chinese. Okay, this guy speaks a little bit of Chinese. I don't speak any Chinese. If I wrote a comment in Chinese, that would be dumb, okay? If I wrote code in Chinese, that would be strange, but the code still works, right? But if I write a comment in Chinese, the whole point of a comment is to convey information to another programmer. And if my programmers don't speak Chinese, then why am I writing comments? So I believe that not the whole point, but a big point of writing tests is for other programmers. And if the tests are not clean, they're not readable, they're not easy to maintain, they're not easy to understand, then A, they won't last, and B, they won't do their job of explaining, then I lost a big chunk of the reason that I have tests in the first place. I'll also throw in there that I think partially velocity only really will that benefit of velocity will only be had if you have clean tests, because without it, sure, it might save some in having CI and CD, but you'll lose some in having to fix your tests. So not sure you really gained anything. And of course, the satisfaction component with ugly tests just doesn't exist. So screw that. So we have to have clean tests, but we know it's hard, right? Of course, writing clean code in general is hard. Yeah, sure. But clean tests are just like more important than clean code, are also harder than clean code. Why? Well, we're in a rush. Of course, we're always in a rush. We're in a rush when we write regular code too. But for tests, we're especially in a rush. Why? Because we're not even sure we should be doing it all together. We just barely convinced our bosses that it was justified. So we had to like beg for permission to spend time on tests, and now you want to spend more time on tests? It's a hard sell. So we rush the tests. On top of that, we don't know how to write clean tests. What do I mean by that? We have all these best practices on how to write clean code. Yeah, I mean, Bob Martin wrote a whole book on it. Yeah, but clean tests, like they can present all these other issues like mocks and a lot of what testing is repetition. You keep trying the same thing in different edge cases, so I end up with a lot of copy paste, and I have to keep creating all these kind of like fake data things, and it just feels like there's some inherent mess in this that I somehow can't get away from. So not only am I in a rush, I don't really know what I'm doing. Is there a better way? I think there is. And I'm going to present to you a few guiding principles and then a few patterns you can use. Guiding principles, number one, it should read like prose. That means that it should read like a story you're reading, like plain English, or Chinese if you write your code in Chinese, okay? What do I mean by that? This is an example of a test, okay? You can read it. And it's pretty straightforward. It checks that when it's loading, we render the footer, the end. Given that the app is in a loading state, the footer should be visible. It's pretty easy to read, okay? I don't have to understand anything about it. What else? It's short. It's literally 4 lines, and one of them is just the closing braces, okay? So yeah, let's look at that again. Pretty short, pretty clean, pretty easy to read. I like it. Some people will really push it here and say that your test should only have one expect in them, or all kinds of other rules of thumb. I'm not going to push it. That's kind of like Uncle Bob. I hate calling him Uncle Bob. It makes him sound like some kind of creepy uncle. Bob Martin. It's like Bob Martin's rule of 3 parameters. I don't know if it's a good rule. 3, why 3, not 4? Why 2? It's a guideline. Don't take it too seriously, okay? But the concept is important. Keep your tests short. Keep them focused. But most of all, do like what you did when you were a kid and your mother asked you to clean your room. So when I was a kid and my mother would ask me to clean my room, it took me a long time to figure this out, probably till I was about 7, I don't know. I used to think, I have to clean all this junk, all these toys, what am I gonna do with them, right? So I figured out 2 things. One is, if you make your bed, your room looks much cleaner, okay? I don't know why, but it's like, if you have a lot of clutter, but your bed is made, clean. If your bed's not made, but all the clutter is still there, just the opposite, whatever, you get my point, right? Like, making your bed just makes it look much cleaner, but that wasn't the example I wanted to give. The example I wanted to give was, the other thing I figured out is if you have all this clutter, you take it, you stuff it in the closet, you slam the door, okay? And it looks like that. That's how you clean your room. And that's how you clean your tests, okay? Some of the mess you're not gonna be able to get away from. There's just no way, because you have to do all this stuff. You have to set up these mocks, but don't have them in your code, okay? And now we'll look at some patterns for how to achieve this. The first pattern is what we call the given, when, then pattern. What does that mean? A test can be broken up into 3 sections, okay? The first is given, in other words, the initial state that you want to set up for the test. The when is what you want to do in the test, what you're testing essentially, what action or behavior that is under test, sometimes called the unit under test. And the then is the expectation. It looks like this, okay? In this example, I say, I want to choose the best dev stack given some audience. So if the audience is the React.io meetup, which means that's my given. Okay, given that the audience is the React.io meetup, my function that I'm checking is I have a function in my code called getBestFedStack. It's a method, all right? That's my when. When I check for the getBestFedStack, I expect my then is I expect that it will contain React. I usually like to put a line break between each of these 3 sections to show it's great if the whole test is 3 lines just like this. Sometimes one of the sections is 2 lines because I have to create a variable. Okay, I still break into these 3 sections so I understand when I'm reading it. There's a setup, the behavior, and then the check. That's the first pattern. The second pattern is builders. Now for this we need a little bit of an example. So we're going to go back to our classic example. Question?
Yeah. Can you go back?
Sure. No extra charge.
One more.
What for that?
Yeah. Where would you write the given audience function?
We'll get to that.
Or outside?
Outside the test, not inside the test. That's the point. Okay, and I'll show you where. Really, I probably stuff it on the bottom of the file if it's local to the file, just to this. If it's just for this describe or whatever, I might put it on the bottom of the describe. Basically, as close to the test as I can, not in the test, but where it's shared. Why not in the test? Because I want the person who finds this test failing, they don't know why, they come to the test and right away they just see, given I have an audience, they should trust that given audience works, okay? The reason it's failing is not because the audience definition is wrong. Sometimes it is, in which case you're probably using this given audience function in a lot of places, and a bunch of tests would have failed, and then one little fix fixes them all. Good? But builders, so I have this this test that is checking that you can add a to-do to a to-do list, okay? And this test also has a given when then. My given is a certain to-do object. My when is I'm adding it to the to-do list, and my then is checking that it's there, okay? The to-do list has a get method that returns the to-do. And if you look at this test carefully, you notice something strange. I have a title there on the fourth line, and that seems redundant. Like, it doesn't seem necessary. I mean, I understand why I have the ID there. The ID is important. It's part of what I'm checking. The get method on the to-do list object expects an ID. But why do I have the title? So I'll tell you why I have the title. I have the title because it's a required field, and somewhere else along the chain, everything's gonna fail if I don't have it there. In real life, every to-do has a title in my domain, and in real life, this will never be an issue. But in my tests, I don't really care about the title, but I don't want my tests to fail just because of some unrelated error to what I'm checking. So I have to add the title there. Except right away you start to see this is going to be a problem because I have this in a bunch of tests that I have to set up to do. And a lot of them I don't care about the title. Maybe there's one that I care about the title and I'm checking things that related to the title. In most of them, I don't care about the title. So why do I have to have this extra noise of the title in every test? Oh, and by the way, if I add another required field, like let's say I have description, and tomorrow description gets added and it is somewhere in the code flow, there's an expectation that description won't be undefined. Now I have a million errors of the description being undefined, and a lot of my tests are failing, and that's a problem. So we solve that with builders. Here's a simple builder, just an example of how you might write it. I have a class that has on it some methods, and what this class guarantees is that when I call the build method, it will return me a valid to-do, whatever a valid to-do looks like. If tomorrow a valid to-do has another required field, there will be some random noise in that field, but it will be valid, okay? And whatever widths I put on it, in other words, with ID, that's what I'm saying. That's what I care about for this test. For this test, I care about the ID. Everything else, just fill with fake data. Okay? So now I have it to do with this ID. Everything else I don't care about. But you see in another example, I don't even care about the ID. I just care about the attachments. So in this one, there's a random UUID something for the ID, and the attachments are specified. And here you see I did something clever. I have since attachments is a somewhat rich object, I have a builder for that too, and I can nest the builders. So I say, okay, give me a to-do. I don't care about anything in the to-do. I just care that there will be one attachment in it. And the attachment, I don't care about anything. Literally, I don't care about anything, just that it will be a valid attachment. And that's all I need to be able to do this test, which is checking that I can delete an attachment. Okay? In some other tests, I might care about more things. Now, if you're looking at this, you're probably starting to think, okay, it's still pretty clean. It's just, a given when then, but it's not so short anymore. So we're losing one of our principles there. And you can imagine that it's going to get longer. Right? This is just what the setup is going to look like for some tests. Because what if I need two, or now I need one that has 3 attachments. I don't care about anything, but I know that it needs to be 3, and I know that it needs to be valid. So my builder is starting to make a lot of noise. And so for this, we introduce another pattern that I call the a-foo bar pattern, because I don't have a better name for it. So if anybody has any suggestions, I'm game. What is it? This is kind of like the question we got here, which is where do we put the mess, so to speak, right? Where do we hide the mess? So I usually hide the mess inside a function that looks something like this, okay? I call it a-foo bar because I usually start it with a or an. It's give me a to-do with attachments. And in this case, since I'm going to use this in a lot of tests inside of this describe, and a lot of them I'm going to need, say, oh, I need a to-do with 1 attachment. I need a to-do with 5 attachments. Right? And that's all I care about. I write this function. I say it takes a length variable. That's just a number. Don't check me on the code here because I wrote it without running it in any JavaScript environment. There's probably a bug there. You get the idea, okay? And then I can use this inside of my code. I'm back to simple 3-liner. Give me a to-do that has 3 attachments, delete 1, check that there are 2. In another test, I say give me a to-do with 0 attachments, delete 1, and I don't know what's the expected behavior there, but the expected behavior would be what I want, etc. Where do I put this function? As close as I can to the test, so that doesn't just create noise, but as far away, first of all, not in the test, as far away as I need to, so that it can be shared by whoever needs to share it. Meaning, if this describe is the only place where I care about creating to-dos with an arbitrary length of attachments, I'll put it inside the describe on the bottom. I like to put it on the bottom so that right when you open the thing, you just see the actual important bits. If it's going to be used a lot of places in the code base, I'll probably put it in a helpers file, etc. finally, I get to the last point, which is usually, it's really the same concept, but with a spin toward the ETE and Selenium protractor kind of concepts, Puppeteer, or whatever. And we call them drivers. And the driver essentially will be your interface from your code, from your tests, to how your HTML on your app looks, okay? Your test shouldn't have to deal with things like like query selectors and locators and all that kinds of stuff. It doesn't really care. You want your test to look something like this, okay? I have a to-do list driver that I probably initialized inside of before each. I say, load the page. When the new to-do button is clicked, I expect the new to-do modal to be opened. That's really all I want to know, okay? What does the driver look like? So just an example, I don't even know what framework this is using. I made it up, okay? I don't think there's any framework that looks exactly like this, but this is the concept. You probably have a basic page driver that has some kind of function like driver navigate to, and it takes care of how your framework wants you to navigate to a page, and you say, okay, when load page inside the to-do list, then navigate to the to-dos. And then you create some whens and some gets, basically different blocks that will have inside of it all of the whens that you might have inside of your driver, all of the getters that you might have. In this case, here is where we tell the test framework, okay, when I tell you to click the to-do button, this is what I mean. These kinds of, you get two things out of this. A lot of reuse, so that when you move something around in the HTML, you change some small little thing in how the selectors are or the structure of your HTML. If your selectors were complicated and they used kind of nesting, CSS selectors and whatever, and one small change to your whole DOM could break everything in your test, it all gets localized here, and it also hides the mess and the ugly stuff and returns your tests to be what we want them to be, which is simple, clean, nice, 3-liners. That's really it for how to write clean test code, okay? Except somebody right now is thinking, I have an idea. What if I can write tests without code at all? The cleanest code is the code doesn't exist. That's also a quote from Laura Franco, okay? Just so you know. Pretty much everything I have is straight out of him. So he says the cleanest code is code doesn't exist. So if you don't have code for your tests, I don't mean you don't have tests. If you don't have code for your tests, then you don't have ugly code, which is like very wise. Boom, right? And in order to accomplish that, you can use something like, and probably not something like, you can use TestMio, which is something you can look into. It's a topic of a different talk, but it's a tool that you can pay some money for and have the ability to write UI, functional UI tests without having code, okay? It won't replace your unit tests and all that, but it'll replace your, hopefully, or the idea is it might replace your Selenium, Puppeteer, whatever tests. Well, I don't know. Not that I don't know if it's good, I think it's great, but I don't know if you really solved your problem with mess, okay? Because it's not true that if there's no code, there's no mess. You can make tests messy too, right? So if you're not familiar with testing, this might not make a little sense to you, but if you are, you look at this and you just see, okay, a bunch of little steps that don't really mean anything to me, and then I'm gonna fast forward, and this is exactly the same test, okay? I just cleaned it up a little. Does exactly the same stuff, but it's really hard to see. I put readable things here, okay? I named the steps, entered some tweet text, click the tweet, retweet the tweet. I'm checking actual, readable things, whereas in the previous one, I'm looking at, I don't know, click inside this input, press enter, then click this, and then hit tab, then type this text, which isn't really meaningful. This is similar to hiding all of that junk inside of a driver. Because again, if we were using drivers, we'd want it to see when you write a tweet, not when you focused on this element that has this selector, and then you pressed enter, and then you entered this text, and then you press this other thing. None of that really matters. That's not important. So even if you go to a no-code kind of solution, you still need to think about clean tests. It's the same principle. The fact that you don't have code doesn't really mean that you get away with whatever you want. All right? So don't try to be clever. One last thing before you go. One thing I learned being a developer for a little while is that whatever you do, people will copy, okay? It doesn't matter if you write in the code, to do this is bad, we need to fix this. People will copy it. They might even copy the comment, okay? So like, let's say you're writing POC, we're just adding the tests for the first time. We're adding Jest, we're upgrading, we're making a new framework. I don't know what we're doing, right? We're onboarding our team to this new thing, and it's just the concept. Of course, later we'll clean it up. you're never going to clean it up, okay? Dan Abramov, who's the Redux guy, so a little while back, he tweeted something like, I don't remember what it was, but something, it seemed to me like he was frustrated that people really copied him in Redux. Like, when he presented Redux at a conference, he was trying to say, like, here's a general idea. I don't mean you should actually write a big switch statement, right? It was just like some, I'm feeling out the idea. Of course, you should figure out how to make this make sense. It's not going to work that way, okay? So I fully support you being a champion in your team. Be a champion for tests. Be a champion for whatever new framework. Be a champion for all that stuff. But if you do that, accept your responsibility, because you have a great responsibility. You're going to be a champion for your tests. You're going to write tests. People are going to copy them. So clean your tests. Thank you very much. I'll take questions.